In this video, we want to find the area of the segment shown in the diagram here. So it says find the area of the segment shaded in blue. So we're looking for this area right in here of a circle with radius 8 feet formed by a central angle of 70 degrees. So this angle right here is 70 degrees. And then the radius of the circle is 8 feet. So we know these two sides are the same length. So this triangle is formed here. It has an angle of 70 degrees, is isosceles. Two sides the same length. So we know that this angle here, and this angle here are the same. Same measure. So 180 minus 70 degrees gives us 110. So those two angles have to be 55 degrees. So there's a formula for the area of a sector, which would be this whole thing right here. We have several formulas for finding the area of a triangle. I've done some of those, I've used some of those in previous videos, so if you want to pause the video and see if you can work this out, go ahead and do it, and then I'll be back. Okay, let's go ahead and look at this. The area of a sector with central angle of 70 degrees is given by 1/2 whatever the radius is squared multiplied by the angle theta. Now with this formula, theta has to be in radians. Okay, theta has to be in radians. So all you would do then to find the area of the sector would be 1/2 radius squared, that's 8, that would be 64, and then times, so this would be set up this way. So to find the area of the sector then, we would have 1/2, and then the radius squared. That's 8 squared is 64, so this would be 64. And then times the angle in radians. So we would multiply this by 70 degrees. And then we multiply this in turn by a factor of pi over 180. That's a conversion factor going from degrees to radians. So pi, the degrees here would cancel out, and I would multiply by pi over 180 times 60, of course, comes to 1/2, and that would give me the area of the sector. Now we subtract the area of the triangle there, and that would give me the information we need, the area of this segment right here in blue. So the formula that we would use right now is the one that tells you that if you have all three angles given, and we do, we have 70 degrees and the other two are 55 degrees, and all we need is one side. Here we have two sides because the radius of the circle is 8, so we have 8 here and 8 here. So the area of the triangle will be given by whatever side is given. Let's just say we have 8. It's 8 squared. That would be on top. And then on the bottom, it's the angle opposite the side you pick. Doesn't matter which one you pick because the angle opposite, if you take this 8 over here, the angle opposite is 55. So it's 2 times the sine at 55 degrees. And then on top, you would have the sine of whatever two angles are left. So it's another 55, so this would be the sine. (55 degrees), and also times the sine of 70 degrees. So you compute this out, and that gives you the area of the triangle. With this right here, you compute the area of the sector, subtract those two areas, and that gives you the information that we need. And just so that you can see it a little bit more clear here, clear this, and I have it set up over here. So this is what I just wrote up above. Area of the sector, this is 0.5 or 1/2. The radius squared, that's 8 squared 64. And then times the angle in radians. So all I did here was 70 degrees multiplied by pi over 180. And we get this result here, 39.095. And then the formula of the area of a triangle when you're given all three angles. And all you need is one side. You can compute the area. So it's the given side squared, okay, was 8. The radius, 8 squared, 64. Then on the bottom you had 2 times the sine of the angle opposite that given side, which is 55. And on top you have the sine of whatever 2 angles are left, 55 again, sine of 70. And you get 30.070. Do the subtraction there, and you get 9.025, or 9.03 if you round it to 2 places, square feet. Square feet. And that's the result. Now the two formulas, again, that we used here, this one right here, and this one I went over in a earlier video. So for this one, we're given the angles ABC, and one side is all you need. So the formula says the area then is the square of the given side over twice the sine of the angle opposite, whatever side is given. Okay, side A, opposite angle A, and then on top you have the product of the sine of the other two angles, sine of B, sine of C. And of course the other formula we use, the area of the sector of a circle of radius r formed by a central angle of theta radians. Again, for this formula, it has to be in radians, and theta has to be in radians. Found the area of the sector by leaving 70 degrees as is, and just saying, well, the area of a circle, the area of the circle would be pi times r squared. So this would be radius squared at 64, so we would get, that would be the area of the circle. And then I would multiply that by 70 over 360, the portion that I want. So I'll say times 70, enter, and then divide by 360. The total degrees in a circle. And I get 39.095, which is the same thing I got over here. And I didn't have to compute or change the angle to radians. Thanks for watching. We'll see you next time.